Okay, so for this exercise, I'm going to show you again an example of a payback period using equal cash flows. We're going to be using exercise 12-2, but we're using the data from 12-1, and we're going to compute the payback period for these MP3 players. And notice that the initial investment up here is $1 million. And so what you'd have to do, again, this is exercise 12-2, to get the payback period, you'd have to initially basically take that $1 million and you're going to divide by the 371,500 because it's an equal amount, and that's how you would compute the actual payback period. So you can see from the official answer, once you take that $1 million and divide by the 371.5, you get a payback period right at 2.69. And the other part of the question was talking about the residual value of the investment. Well, in this case, it wouldn't be affected because it comes after the 2.69 years. So you can basically ignore it. And it does pass their initial screening test, which is 3.5 years. So this might be an acceptable project. Okay, so the next one I want to walk you through is the payback period with unequal cash flows. And this is going to be the DVR problem. And again, remember that the initial investment was $1 million. So the way you'd want to do this is you have to accumulate it year by year until you reach that $1 million. So you notice after year 1, you've recouped $530,000. After year 2, you've recouped $390,000. If you stop at that point, you add these together, you get $920,000. So note you're $80,000 away from recouping your initial investment. So what you do is you take that difference of $80,000 and you're going to divide that by 330. That's the cash flow coming in from the next year. And whatever fraction that is, you're going to add that to 2 because it's 1, 2 plus whatever that fraction is. And that would be your expected payback period for unequal cash flows. So, here's the official answer. Here's that 80,000 again that you're dividing by the 330, and you get 0.24. You add that to 2. Again, you'd say that the payback period would be right at 2.24 years. All right, the next one I want to walk you through is the accounting rate of return. This is going to be exercise 12-4. And again, we're going to be using the MP3 players to do the calculation. And so to do this, we have to know, of course, we have to know what the depreciation is going to be. So remember, it's going to be $1 million. It's going to be straight line method. And what you would do is you would divide that by 5 so that your annual depreciation is going to be $200,000. And the way you do this particular type of return is what you do is you take the average annual income from this asset. So what you do is you take the 371,500, you subtract out any depreciation, which this case is 200,000, and then you would divide by the initial investment, which is $1 million, and that's how you would get the accounting rate of return. So here's your official answer. Again, here's that average income cash flow from the asset. You subtract out that depreciation. Here's their calculation of the straight line depreciation. You divide by the initial investment, and you'd get an accounting rate of return right at 17.15%. And then the second part of this question, in this case, the residual value would affect the accounting rate of return because that does affect your depreciation. So note what would happen is that $100,000 residual value would actually change the depreciation from $200,000 down to $180,000. So then what would happen is here's your calculation. You take the 371.5 minus the new depreciation of $180,000 divided by your investment, and note what happens is now your rate of return changes to 19.15%. Okay, so I also want to give you an illustration on how to do the accounting rate of return with unequal cash flow. So we'll use the DVRs in this case. So what you do is because they're unequal, you're going to come up with an average. So you add them all up. In this case, it's going to be 1,545,000. You divide that by 5, and so this is the way you're going to calculate an average income from this particular asset. And then once you get that, then you subtract out the depreciation and divide by the investment. Other than that, that's the part that changes, is because it's unequal cash flows, you come up with your average by dividing by 5 in this case, but everything else is going to be the same. So here's the official answer. Notice once you do divide by 5, here's that calculation. Once you do divide by 5, the average yearly income is $309,000. You subtract that $200,000 depreciation, divide by $1 million. You're going to get an accounting rate of return in that case of 10.9%. And just like the other problem, that residual value does affect depreciation expense. So note again, your depreciation expense does change to $180,000. So you take again the 309 minus the 180, divide by your initial investment, and that's going to change your accounting rate of return to 12.9%. Okay, so I want to show you an example of how to do a net present value problem. So this is going to be short exercise 12-11. So what we have here is we have Connor's Music is considering investing $650,000 in a private lesson studio. No residual value. It says the studios are expected to result in annual cash flow inflows of $90,000 per year for the next 10 years. Assume that they use a 12% hurdle rate. Again, that's going to be the rate we're going to be doing the discount because the $90,000 is essentially going to be future value. We want to convert that to present value. So what we're going to have to do is we know that right now we're going to make an investment of $650,000. So that's going to be our initial cost. And then what we'll do is we'll take that $90,000 and we're going to multiply by our table factor, again, to compute that into a present value. The table factor will be using n is equal to 10 periods, an interest rate of 12%. So you go to your present value annuity table because it's going to be an equal amount. Once you find that table factor, you'll multiply it by 90,000. You'll net it with the negative 650. And then as long as you get a number that's greater than or equal to 0, you would say that this might be an acceptable project. Again, I'll show you the exact numbers on the next slide. So here's the official answer. The table factor in this case would be right at 5.65. Once you multiply by the 90,000, you get a present value of those future cash flows of 5,085. You net that with the negative 650. Notice you get a negative net present value. That is not greater than or equal to 0. This would not be an acceptable investment. Okay, so we're going to look at short exercise 12-12, and I'm going to show you how to calculate the internal rate of return, again, with equal cash flows. So what we do is we're using the data from 12-11, and what they do is you got a $650,000 initial investment. What you'll do is you take that $650,000 and you're going to divide that by 90,000. And when you do that, you get right around 7.22 as your number. So what you would do is you would take this number, and again, you're trying to find it in your present value table. And because it's going to be 10 years, you'd be using n is equal to 10. So you go to that row, and you're looking to see where does the 7.22 fall in the table. And what you're going to find is it's going to fall between 6 and 8%. And that would be your estimate for your internal rate of return. And so here's the official answer. Again, this is must be a typo in the solution. That should really say n is equal to 10, not n is equal to 9, because they said it's 10 years. So again, you're still going to get between 6 and 8% because that's where the numbers fall. Again, I don't know why they're saying 9 years. They should be using 10 years, so I hope that does not confuse you. But again, go to your appendix, and once you divide, here's the factor, which is 7.22. You're looking to see where that falls into the table, and you're going to find that it's going to fall right between the columns, and you should get about between 6 and 8% as your IRR. Okay, so I'm going to show you another problem with a net present value. This is going to be exercise 1227A. You're going to be using the MPV method to look at two different types of projects. So we got project A, which has an initial investment of $290. They've got 7 annual cash flows, so you're going to have n is going to be equal to 7. It's going to be $63,000, and we're going to be using a hurdle rate of 14%. So I'm going to write that there. So then project B is going to be a cost of $395. We're going to be using n is equal to 10 for these future cash flows, and an interest rate right at 10%. So what you'll do again is you'll use these numbers. You'll go to your table for project A. You'll take the $63,000. Once you find the table factor using n is equal to 7 and I is equal to 14%, you'll multiply those out to get your present value of cash inflows. You'll net that with the 290 to get your NPV. Same thing on project B. Again, you'll use n is equal to 10, I is equal to 10%. You're going to take the 71,000, multiply by the table factor. Once you find that, and again, this is going to be your annuity table because it's going to be equal cash flows. And then you're going to net it with the 395. And again, that's how you'll get your NPV. So you'll note on project A, once you use n is equal to 7 and I is equal to 14%. Here's your table factor. Multiplied by the cash flows, you get 270, 144. You net that with the initial investment. Notice you get a negative NPV. That is less than 0, so that's not very good. Project B, here's your table factor. Again, using N is equal to 10 and I is equal to 10% multiplied by the 71,000. You get a present value there of 436,295. You net that with the 395. You get a positive cash flow of 41,295. That is greater than or equal to 0. So this would be an acceptable project, Project B. So then the other part of the problem asks for the maximum acceptable price. And what that's basically going to be is going to be the present value of those cash inflows. So for Project A, it turned out to be 270, 144. And for Project B, it turned out to be 436, 295. Okay, so the last one I'm going to walk you through this is exercise 1231, capital rationing. And so what we're going to look at is the profitability index. So we've got equipment A, B, and C. They've already given you the present value of cash inflows. We've got the initial investment, and they've already done the calculation for NPV. And so in this case, what you want to do is you'll take these present value cash inflows and you're going to divide by the initial investment for each of these. Relatively speaking, is going to give you what's called the profitability index. And the idea is it gives you a relative profitability, relative based on the initial investment. If you look at the three equipments, note that equipment C is the most expensive, although it does provide the most cash flow as well. And of course, equipment A is the least expensive, and it does not give you as much cash inflow. But again, the question says is which investment should they pursue at this time? And again, I'm going to walk you through the exact numbers, but what we're going to be doing is we're going to be taking this present value of cash inflows, dividing by the initial investment, again, to get a relative number. It's called the profitability index. So as you can see for equipment A, B, and C, once you divided by the initial investment, equipment A had a profitability index of 1.04. Equipment B is a little bit higher at 1.1. And equipment C looks like it is the best one. It has the highest factor. Highest profitable project should be equipment C, which is at 1.11.